Okay, these are the notes for day 7. And we're going to start by labeling our sides. Our vertexes, or our angles, are labeled with the capital letters. And then each side is labeled with a lowercase letter. And the letter matches from the side and the angle opposite the side. So here's angle A, and side A is opposite of it. Angle B and side B is opposite, and C, side C is opposite. Okay, now we're going to remember our SOHCAHTOA. The first part is sine is opposite over hypotenuse. So I'm going to write that down right here. Sine of A is opposite over hypotenuse. So looking at our triangle, the side opposite of A is this one, side A. And the hypotenuse is C. Cosine is adjacent over hypotenuse. So looking here, the adjacent means the side right beside it, so that's B. And my hypotenuse is still C. And tangent is opposite over adjacent. So the opposite is A, and my adjacent is B. Now we're going to talk about 3 new type of trig functions, and they're called the reciprocal functions because each one is a reciprocal of a function we already know. And I'll remind you that a reciprocal, like a fraction, a reciprocal is where we flip it upside down. So a cosecant of A is actually the reciprocal of sine. So it's 1 over the sine of angle A. But how does that work on our triangle? Well, sine A is still the same thing I had before, and sine was opposite over hypotenuse. So if I take the reciprocal of opposite over hypotenuse, what I get is hypotenuse over opposite. And then if I look at my triangle, the hypotenuse, that's still C, and the opposite angle is still A. So what I notice is if I compare sine and cosecant, the answers are reciprocals. Here we have A over C, here we have C over A. These other ones work the same way. Secant is the reciprocal of cosine, and cosine was adjacent over hypotenuse. So the reciprocal of that is hypotenuse over adjacent. And so that's C over B. And lastly, cotangent is the reciprocal of tangent. And tangent was opposite over adjacent, so the reciprocal is adjacent over opposite, which is B over A. So now we're going to use these new trig functions with a couple of examples here. Okay, so the first one says the sine of L. We know sine is opposite over hypotenuse. So the opposite is 15 and the hypotenuse is 17. Then we say, can that be reduced? Nope, that one's good. Our second one here is secant. Well, secant from here is 1 over cosine, or hypotenuse over adjacent? So looking at my angle here, L, the hypotenuse is still 17, and my adjacent is 8. And finally, tangent of K, oh, look, they change which angle we're looking at. So I'm going to be considering angle K here. Tangent is opposite over adjacent. Starting from K, the opposite is 8, and the adjacent is 15. Okay, and my last one on this page. This one, you might notice that there's nothing filled in on this triangle here. Here is the information that they did give us. And they want us to use this information, the tangent is 9 over 12, to fill in the triangle. Well, I know that tangent is opposite over adjacent. So they want me to make the opposite side 9 and the adjacent side 12. So I go here, my opposite side is this one, so that's 9, and my adjacent side is 12. So how can we find the missing side? Well, with right triangles, we can always use Pythagorean theorem. A squared plus b squared equals c squared. And the only thing we have to remember is c is the hypotenuse, that's the longest side. 9 squared is a, 12 squared is b, and c squared. This is 81 plus 144. So that gives us 255 is equal to c squared. And then we take the square root of both sides, and we get 15 is equal to c. Now you may remember that when we take the square root of both sides, we always have to do plus or minus. Why don't we do plus or minus on this one? Well, because a minus doesn't make any sense. That side can't be a negative 15 long, so the negative doesn't make any sense. So we don't worry about the negative part. But basically we find out this other side is 15. Now that we have our triangle labeled, we're ready to go back and do our parts. The first one is cosecant of A. Well, cosecant is the inverse of sine. And sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So looking at A, the hypotenuse is 15, and the opposite is 9. But are we finished with this one? No, we still need to reduce it. So when we reduce it, we get 5 over 3. Cotangent is 1 over tangent. And tangent is opposite over adjacent, so this is adjacent over opposite. The adjacent to A is 12, and the opposite is 9. And we have to reduce this to 4 over 3. And lastly, we have cosine, but look, they switched angles on us again. So I need to do the cosine of B. Well, cosine is adjacent over hypotenuse. Adjacent to B is 9, and the hypotenuse is 15. And when I reduce this, I get 3 over 5.